the last thing we're going to cover right now is going through and solving trig equations. So if I give you an equation that looks like 2 sine of theta equals negative root 2, I want to get sine of theta alone. So I'm going to divide both sides by 2. And I end up with sine of theta equals negative root 2 over 2. And so before we knew the unit circle, we talked about inverses and taking the inverse to get theta alone and how we can use our calculator to plug in the inverse of sine of negative root 2 over 2. But now we don't really even need to do that if we have a unit circle and if we know that negative root 2 over 2 falls on the unit circle, right? So I want us to remember always, and I always write this, I will continue to write this for the rest of my life, I think, that sine is equivalent to y and that cosine is equivalent to x. For some reason, I've done that since high school, and for some reason, I just can't, like, I get like really flustered looking at the unit circle if I don't have it up there. So I am looking for when y, or the y coordinate, is equal to negative root 2 over 2. So I'm going to go around the unit circle. Okay, well, I have a y coordinate here that's equal to root 2 over 2, but it's not negative. So no, that can't be it. I have a y coordinate over here that's equal to root 2 over 2, but it's also not negative. So no. And then I go down here. Okay, well, I have one here that is negative root 2 over 2. Perfect. And then I have a second one here that's negative root 2 over 2. So I end up with theta equals 225 degrees or 315 degrees. Because if I plugged in 225 to sine right there for theta, I would get negative root 2 over 2 out. Or if I plugged in 315 for theta, I'd get negative root 2 over 2 out. But if we want to be super mathematically correct about our answers, then my preferred way of writing this would be 5 pi over 4. I'm a big fan of radians. Comma 7 pi over 4. And then I would do plus 2 pi n. And if you remember this 2 pi n when I talked about converting from degrees to radians, the 2 pi n is just really specifying like when n is an integer, aka a whole number. This is saying, okay, like 5 pi over 4 makes it true. And then if I go around the circle all the way around 2 pi again, I come back to 5 pi over 4, but 5 pi over 4 is really now 15 pi over 4 because I've added 2 pi. I've gone around the circle 2 pi, okay? And so this is the most mathematically correct way of saying it, solely because I didn't give you a constraint on, okay, well, in the circle, like in the constraint of 2 pi, what are the angles? And if it were just in the constraint of one circle, it would be 5 pi over 4 or 7 pi over 4. But if I don't give you the constraint, then it could go on for forever, right? So that's why this is like the most mathematically correct way to write it, just because I didn't give you a constraint. So that's how we solve trig equations. And I can do one more. I'll do it in a different color, and maybe I'll do cosine this time. So if I give you like 2 cosine of theta equals 1, okay, I need to get cosine of theta alone, so I'm going to divide by 2. So those 2's cancel, so I'm left with cosine of theta equals 1/2. And again, we could go back to our calculator and do the inverse of cosine like we learned like when we were talking about inverses. and like you probably did last year when you were looking for an angle, but now we have the unit circle, and I'm a really big fan of just using the unit circle. So I am looking for, I know that cosine is x, so I'm looking for when my x coordinate is 1/2. So I'm going around, okay, I see an x coordinate here that's 1/2, perfect. I'm still going around, that's -1/2, that doesn't count. Over here is -1/2, that doesn't count. But I see a positive 1/2 here for my x coordinate. So I have two angles, just like with the other one. And so these angles are 60 degrees or 300 degrees, right? And you could write like plus 360 times n. That's just kind of like funky to write it because we usually like to use radians when we talk about the unit circle. But I'm going to also write the answer in radians. That way you can see it. So pi over 3, comma 5 pi over 3 plus 2 pi n. And I think it's really important to specify what n is, right? So n is an integer. Okay. So those are two examples of solving trig equations, and that should help you with your Desmos activity.